A manufacturer states that the average lifetime of its light bulbs is 36 months. A random sample of 50 light bulbs yields a mean of 32 months with a standard deviation of 8 months. Test the claim at alpha equals 0.01. We always start by stating the claim and the complement. The claim is that the lifetime of its light bulbs is 36 months. So the claim is the mean is exactly 36, and the complement to that is not equal to 36. Step 1, I have to decide which one is the null hypothesis and the alternative hypothesis. Recall the null hypothesis is always the one with the equal sign. So the mean is equal to 36, and the alternative hypothesis must be the mean is not equal to 36. Notice that in the alternative hypothesis we have the mean is not equal to 36. So this must be a two-tailed test. We're going to reject the null hypothesis if the value is too low below 36 or too high above 36. This is a two-tailed test. So at the end I need to double the p-value. Double the p-value. Step 2, we're going to state alpha. Alpha is equal to 0.01, and alpha is always given for a hypothesis test. Step 3, I have to decide if I'm going to use T or Z, and that depends on the degrees of freedom. N minus 1 is equal to, we have a sample of 50 light bulbs, so 50 minus 1 gives us 49. The degrees of freedom is 49. That means we are going to use T. We're going to use T because this is less than 1000. T is equal to x bar minus mu divided by s over the square root of n. So let's find the value of x bar. X bar is the sample mean, and it says of the 50 light bulbs, it yielded a mean of 32 months. So the sample mean is 32. The mean of the population, they claimed it was 36 months. So mu equals 36. The standard deviation is 8 months. And the sample size, we selected 50 light bulbs. So n is equal to 50. T is equal to 32 minus 36 divided by 8 over the square root of 50. Using the calculator, T is equivalent to negative 3.54. Since we're using a T statistic and we're doing it by hand, we have to bound the value to find the p-value in step 4. Since we're doing this by hand, we have to bound the T statistic to find the p-value. In step 4, we're going to find the p-value. Since this is a t-test, we're going to look at our t statistic from earlier, which was negative 3.54. We are going to attempt to bound this value with our t table, since we're doing the problem by hand, in order to find the p-value. Our degrees of freedom was 49, so we'll go to the closest row, which is row 50. We have our degrees of freedom is 49, and the closest one to that is a degrees of freedom of 50. So let's go to row 50 and try to bound our t statistic, which was 3.54. 3.54. Now, unfortunately, in this case, we cannot bound 3.54. These numbers at the very far right cannot bound my test statistic, but I can bound it on the lower end of 3.49. So that is less than my 3.54. So we'll go up. Since we can't bound it completely, we can still bound it on the lower end. So our p-value has to be less than 0.005. Our test statistic is further than the table can provide, so our p-value must be less than 0.005. So our p-value now has to be less than 2 times 0.0005. We have to double the p-value since this is a two-tailed test. So the p-value is now less than 0.001. In our case, we could not bound the p-value, but we knew that it had to be less than double that of 0.005. So the p-value has to be less than 0.001. In step 5, I am going to state our conclusion. I always ask, is the p-value less than alpha? Remember, the p-value was less than 0.001 and alpha is 0.01. So yes, the p-value is less than alpha. We do reject the null hypothesis. There is enough evidence to conclude, and remember, your conclusion is always in terms of HA. So if you look at HA, our HA was the mean was not equal to 36. So we do reject the null hypothesis. There is enough evidence to conclude the mean is not equal to 36 months. Since we do reject the null hypothesis, there is enough evidence to conclude the mean is not equal to 36 months. If we are going to do the problem on the computer, let's enter the standard deviation of 8, the sample mean of 32, sample size is 50, the mean is 36 months, and we want to select not equals because this is a two-tailed test, and we'll select calculate, and here is our statistic, negative 3.5355, and our p-value is really small, 0.009. If you are doing this on a statistics calculator, you do not need to worry about bounding the t-value. It is exact from the computer, so we don't have to worry about bounding. It makes our life so much easier when we use technology. Example: weights of pennies minted after 1982 are supposed to weigh less than 2.5 grams. A researcher is interested in determining whether the pennies minted after 1982 are in fact less than 2.5 grams. He randomly selects 17 pennies minted after 1982 and obtains the following data. So we have a list of pennies, and there are 17 pennies listed in the data set. We are asking if the weight of pennies is less than 2.5 grams. The claim is the mean is less than 2.5. So the complement to this is the opposite. The mean is greater than or equal to 2.5. Now we can decide in step 1 which one's the null hypothesis and the alternative hypothesis. Remember, the null hypothesis is always the one with the equal sign. Step 1. The null hypothesis is the mean is greater than or equal to 2.5. The alternative hypothesis, the mean is less than 2.5. In step 2, we'll just have to state alpha. Alpha was equal to 0.05. In step 3, we're going to use the t-statistic. Since our sample was less than 30, we only had 17 pennies. Let's try the problem now on the computer. You want to make sure to select the calculator that says hypothesis test for a population mean with data. And in this case, we have a list of 17 pennies, so I'm going to enter the weights for the 17 pennies in the data here. Now our alternative hypothesis is the mean is less than 2.5, so we're going to click less and leave the population standard deviation blank because I don't know what that is. We'll click calculate, and our test statistic is negative 8.359, and our p-value is not 1.56. If you look all the way to the right, notice there's an E and there's a negative 7 here. What that tells me is I have to move the decimal 7 places to the left. So if I move this 7 places to the left, 1, 2, 3, 4, 5, 6, 7, I know this is a very, very small number. This is a number that's less than 0.0001. So when you see that e to the negative 7, make sure you move the decimal place 7 times to the left. We have negative 8.359. Step 4, the p-value is less than 0.0001. And finally, in step 5, we'll state our conclusion. I always ask, is the p-value less than alpha? Is 0.0001 less than 0.05? Yes, the p-value is less than alpha. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude, and remember, your conclusion is always in terms of HA, so we'll have to say the mean is less than 2.5 grams.